Good day everyone, welcome to Study Smart platform and welcome to MTS315 tutorial where we are dealing with Laplace transform. So in this video I'll be creating some examples with us from the slide, as you can see. So in the previous video we stated some Laplace transform of some standard function. So this gives us 3 over s plus cos 3t, it will be what? S over s square. In this case now, a is 3, that will be plus 3 square, which is equal to 3 over s plus s over s square plus 9. So we have the first example, Laplace transform of 3 raised to the power 3 plus 4. So the Laplace transform of this function becomes 1 over s plus 4 squared plus 1 square. So you can simplify this. So if you add this up, you'll be left with 4s cubed minus 6s over s squared plus 1 raised to the power 3. You can factorize out 2s and you have 2s squared minus 3 s squared plus 1 raised to the power 3. And from the slide you can see that when you have a function of L of Laplace transform of f of t is always a function of s, right? So if you are dividing, that gives you ln s squared plus 4 over s. So and this is the expression for that. So you can move to the next example. Okay, when you have a function in a Laplacian domain, so it is often expedient for us to convert it to the time domain. So the time domain is when it's a function of t. The Laplacian domain is when it's a function of s. So in this subtopic now, inverse Laplace transform, we are going to be converting functions or expressions in Laplacian domains, that is their function of s, and you are converting it to time domain as a function of t. From the slide you can see that inverse Laplace transform is the result obtained when we reverse the Laplace transform process to find the initial function of t. And we have come to the end of these few examples. So if you have any question, you can drop them in the comment box. Thank you so much. See you in the next video. Thank you. But from the slide you can see sometimes you might have to introduce partial fractions before you can simplify your expressions and then invert them to get their time domain, that is their f of t. 1 square plus 1 square. Okay. Then from here we have 5 minus 4, that's 1, that's negative 6. Okay. A is 2, that's 10. So I'm going to be solving some examples for us to fully understand how you can resolve all these Laplacian domain functions into partial fractions, then invert them and get their time domains respectively. So we go from the slide, you can see some examples. Now from example E now, then I've gotten my A, I've gotten my B, I've gotten my C to T. So and this is for this example. So let's move to the next example. From the next example, example H, the beauty of this Laplace transform is that you can apply it to solving differential equations. So, and this is where we are now. We are y bar. So this is now the full expression for the second order differential equation. We are finding the Laplace transform of it. So in this tutorial now, I'm going to solve some examples, and I want us to follow me as I engage us. Thank you. So the first example now, we have from the slide you can see we have the y dt now minus 4y